Okay, so yesterday I started refactorizing C-rectangle class. Today, as I told you last week, yeah, today there are no quiz scheduled. So the last week was the last quiz. Okay, so I started to refactorize the class C-rectangle. So we extracted attributes which are common for C-rectangle, but they are in common for other classes like circle or triangle. Okay, so hope this is clear. But similar to methods to attributes, we can try to point out which methods are in common for all of these classes. So for all geometrical features. So as you know, constructor is not inherited. So for every class, a new constructor has to be defined. Of course, for feature class, we can also have a constructor. So it can, for example, feature, and we can have constructor which let us to set, for example, um, X and Y, and let's say, and colors. So let's assume that feature by default, feature will be red. Okay. Okay, but now look at these methods. So what do you think? Which of them should be, defined in C feature? So which of them are common for all features? So we should extract methods which are not specific for C rectangle. It's okay. So let's start from circumference. So what do you think? Should okay, move. I so maybe we start from the first one. And okay, so what about circumference? Is this method typical for C rectangle or more general? So it should be defined in figure. Okay, it should be different. Yeah. Okay, that's clear. But as an activity, it is, common for all figures, right? So for all figures, declaration of circumference will be the same, yeah, because there are the same attributes and the same value. Of course, they work different, but as I showed you yesterday, if we have base class, there are no problem with overloading the method. Yeah, so we can override the method, but as an activity, this is common activity for all features. Then we have move. is move the same for all features or different? Yeah, of course. This methods can be virtual. Okay, so maybe I will. Okay, so this is okay. What about set size? Is set size? Yeah, no. Why no? Yeah, of course. So even the name of the method can be, the same, depending on feature, it will differ in number or type of arguments. So regarding C++, this is method which is typical for particular feature. So it's not be commonly used. Okay, we could modify this method, for example, to uh, set scale factor, for example. So then we have a single value, and we can squeeze or make our figure bigger, incrementing or multiplying all lengths by a constant factor. So in the case of set scale, okay, this method can be used, for all of these elements, but set size is not such a method. Okay, set position. So look, in set position, in X and Y, so getters, they refers to attributes which were moved to C figures. So it is clear that this method should be defined in C figure. And what about draw? So with draw, we have the same situation which was for circumference. Yeah. So as an activity and function declaration, it is the same for all features, but okay, depending on the feature, they will be drawn different. Yeah. So I can move this method here. So look, even I move circumference and draw, I have to leave declaration circumference and draw in C rectangle because it has to be overwritten. Okay, so based on this class, I'd like to okay, because this methods will be overwritten to uh, to get some benefits of polymorphism, I declare my class, my method as a virtual, yeah, and okay, so let's try to define these methods. So, can we define method circumference for figure? Is it possible? Okay, now we, yeah, in fact, we should, create a new header file for figure, new header file for triangle, but, to make switching between different classes easier, uh, I would prefer to declare them in a single header file. So, uh, but of course, during laboratory classes, you should definitely use separate files. Okay, so what about circumference? So should we define it, or can we define it? So can we, write, and here we should calculate the circumference of this object. In fact, we don't know how to draw and how to calculate circumference, because if I make you to draw figure, okay, you ask me what figure should you draw. So in fact, figure is, an abstract term, so we can't draw it, we can't calculate circumference for it. Yeah? So even there are no object figure, because it's so general term. Yeah, so in C++, when we have method which is common for all child classes, and these child classes are concrete, so yeah, we know what is rectangle, what is circle, and so on. But when we have base class figure, this class exists only in, let's say, theory, yeah, because it's a general group of all objects which has some properties. Yeah, they have legs or area, circumference, but for figure, we can't tell how to calculate it. We need to know what figure it is. So in the case when we have the class which is more general, or we can say abstract, we can denote that particular method cannot be defined here. So this is called an abstract method. And when there is at least one abstract method, the class is called abstract class. So we can do the same for draw. In case of set pose, we can define it, because set pose based on x and y, which we have here. So for set pose, we can write x underscore is equal x, and y underscore is equal y. Of course, if somebody change position, we can, for example, call draw method, and this is legal. So I can call this method, even this method is abstract, but I can set position and to redraw my object. Here I can have another method, let's say rotate. By delta A, so I can write alpha angle, sorry. Angle is equal, plus equal delta A, and draw again. Okay, so let's try to define the class which is called C, maybe not triangle, C circle. So in this case, I will have a radius. And here, radius equal to, let's say, 1. And again, circumference move was set pose. What is the difference between move and okay, move is shifting by vector, so the same for as for set pose. I can move here, and I can write x underscore is plus equal dx, and y underscore is plus equal dy. Okay, so here the structure is not required. Set size, let's say radius. So here I can define it, just in the place. So radius is equal radius. Okay. So now let's try to compile it. So now we have to make something with declaration. So look, C-rectangle is a constructor which takes 4 parameters, but now, because C-rectangle inherit from C-figures, some attributes are not attributes of C-rectangle, so they can be initialized here. So I have to take them, and I can call C-figure constructor, and in this constructor I can pass x and y. Yeah, so I can call the constructor which I declared here. So I have x, y, RGB. Yeah? So C-rectangle, and I can say that rectangles will be blue. Okay. I can also declare a C-figure constructor. So add definition in C-rectangle. So in case of C-figure, I will have x, y, angle, r. So r will be r, g, and b. Okay. And is hidden false. Look, set position was moved from C-rectangle to C-figure. So I have declared it here. Move the same, rotate, setters and getters, and I have draw, which is abstract, and circumference, which is abstract. Okay. So okay, move was moved to C-rectangle. So now in C-rectangle I have set size. After setting size, I can call redraw my rectangle. Circumference is okay. And the figure looks like this. Okay, so now I have to declare also the circle. So I have to declare constructor. Then I have to declare circumference. And finally, I have to define draw. So I can copy the initialization list from C rectangle, but instead of height and height, I can use radius. Radius. Okay. In case of circumference, I have to return 2 times mpi times r. Okay, what about draw? Okay, now I only see out. Now I leave only a placeholder for draw circle. Okay. So now when I compile it, it is compiling. So look, now I'd like to create a vector of C figure type. And to this vector, I'd like to add a rectangle of size 1 by 5, and I can also place back a circle of size, let's say 2. Doesn't matter. So I have a single vector, and this vector can be used to represent different features. Because the base class, so the class cFigure, has abstract methods like circumference or draw. I can use these methods in my program, so I can for out reference element features. See out circumference. And I can also draw it. No? So let's try to run this code. So look, the circumference of my rectangle is 12. The circumference of circle is 12.567. Okay, and here, because the rectangle has size 1 by, let's say, 5, it is drawn here. And when I call a draw, but the object is not rectangle but circle, the placeholder is printed. Yeah. So this is method how I can represent my features. Okay, so now I'd like to show you how we can use these things to, draw these rectangles in OpenGL. So now I shortly switch to lecture about OpenGL to explain you several things, and then we shortly run this code. Okay, so as far as I remember, I finished talking about this slide. So when I tell you about computer graphics, I told you that everything in computer graphics has to be defined as a set of vertices. So any complex object has to be defined using primitives like this. So we can have GL points or vertices which are connected together, or creating an open line stripe or closed line loop. So that's all, yeah, for OpenGL. There are no other, possibilities. So therefore, we usually use more complex or a higher level libraries to create a three-dimensional objects simply. But in fact, still, there are no curves, arches, and other complex, elements. Everything is defined by using vertices and straight lines. So creating vertex, so GL vertex is a very common function in OpenGL. There are several, okay, this function exists in several forms. So they differ in number of coordinates, in type of arguments. So we can have byte type or integer or float or double. What do you think? Why there is so many, combinations or possibilities? Okay, assuming that there is a 1 million of vertices, which is not so huge number, yeah, because for average scene we usually have much more. If particular vertex is defined only by two coordinates of byte type, every vertex takes 2 bytes. So for 1 million vertices, it is 2 megabytes memory, which is required to represent all vertices. If we have 3 vertices of double type, they are 8 bytes. So we have 12 bytes, not 12, 24 bytes per vertex. Yeah. So for 1 million vertices, we have 24 megabytes. Yeah. So depending on our scene, so depending on the resolution we want to achieve, we use different types and different numbers of components. Okay, so here you have code which led us to draw a simple objects in OpenGL. So look, first we have to set color, so red, green, blue. We have to define components, and then we have two commands, glbegin and glend. glbegin and glend defines a group of vertices and the way how vertices should be connected. So in this case, we use a grouping GL polygon. So GL polygon is this group. So it differs from GL line loop in filling the inner part. Yeah. So here we have only, let's say, circumference. Here we have the figure with area. So we can fill it with color. Okay, and what else? So now in this group we define vertices. So you can see that the vertex is minus a over 2. So the first so minus a over 2 is this point. Huh? So minus a over 2 and oh no, sorry. Okay, maybe. So this point is minus a over 2 and b over 2, yeah? Assuming that this is b and this is the a. Here we have minus b over 2. So the center of this rectangle is in the middle. Yeah? So x, there are no, so this is the origin 0, 0. Okay, so you can see that all these vertices refers to, so this vertex refers to this position, this vertex is referring to this position, this vertex is referring to this position, and so on. So this is the way how we can draw rectangle. Here you have code which draws circle. So look, still we have GL line loop, so it is not filled inside. And we have for loop, which changes from 0 to 360 degrees. And for every position, we calculate the localization of point X and Y. We do it based on the angle and based on the radius. So using sinus and cosinus, we can calculate what is the x and y, assuming that the center of this feature is in point 0, 0. So now I can try to copy this piece of code and to use my rectangle class draw. So instead of drawing like this, I can try to draw it in this form. So now I can substitute the red by R underscore, green by G underscore, and blue with blue underscore. GL polygon is okay. So here I have white over 2 and height over 2. And the same for these vertices. Okay. Okay, of course, the commands are not recognized, so I can hash include glut. Oops. And now they should be, recognized as proper commands for OpenGL. What else? What about circle? The same. I can take the circle from here and I can paste it to draw circle. I can take also the way how the colors are set. So GL set color here. And it's not ready yet, but okay. A small step was made. Okay, so of course in GLUT, so GLUT is higher level library for OpenGL. We have an additional methods like wire cube, solid sphere, or wire cone. So you can check it by your own. We can also display texts, which is not the topic for today, but in OpenGL, displaying text is not so easy. So, it's not like in text editor or in console, because everything in OpenGL should be a vector or a texture. So to create a text which is vectorized, so to draw it from vertices, is quite challenging issue, but we can do it simpler. So we can assign for every character a bitmap, a texture, which represent particular character, and then we can, display text by combining these textures. And here you have a shortcode which does it. Okay. So now I'd like to shortly tell you something about transformation, which will be very useful for us. In fact, in OpenGL, every transformation is stored as a homogeneous matrix. And in fact, in OpenGL, we have two matrices. So we have matrix which remembers or keeps the transformation of the object coordinate system, and the second transformation is used for camera. Yeah, so this is separate transformation. But assuming that we use a model view, it means that okay, we are in the coordinate system which is connected with our object. Then we does several things. So we push matrix, so it means store current value of matrix. Load identity matrix. So if we have the homogeneous matrix and it is identity matrix, so it has ones on diagonal and zeros elsewhere. What is the transformation like this? So we have the transformation matrix, which looks like this. So if we have a vertex and we want to transform it, we get the same vertex. So it does nothing. But now for this identity matrix, we perform translate and rotate. And then we can draw our rectangle in the position or in the coordinate system which was translated and then rotated by 45 degrees. So finally, I does GL pop matrix. So I restore the previous transformation matrix. So this matrix, after executing this code, is the same as it was, before. So we can try to do it. So for every draw, I use GL GL push matrix. So I store it. GL load identity matrix to move it to the global coordinate system, and then GL translate, let's say F, and here I have the X and Y and 0 because Z coordinate is not considered here, and GL rotate F. I have angle, and here I have to specify the rotation angle. So the rotation axis. The rotation axis is Z because every figure, which is planar figure, is rotated around the Z axis. So here I can, sorry, I have to specify the axis coordinates or axis versors. Okay, and finally, when the object is drawn, I call GL pop matrix. So that's all. So I can do the same for not only for C rectangle, but for C circle, but also for C rectangle, GL pop matrix. So in this case, my object will be drawn in position which is set by X and Y, and will be rotated by angle, which is the attributes of my object. Talking about OpenGL, I told you that the most important, or not most important, but very important, is the way how we can, show this scene, because the scene is, defined in three-dimensional space or two-dimensional space, but the effect which will be visible is dependent on the camera. So on display, there will be shown only the perspective or the view which is set by camera. And in OpenGL, we have two kinds of cameras. So we have GL ortho. So GL ortho makes something like this. So this is camera, which is it is I don't know what is the name of this object, but it cuts the part or of the scene along the z-axis. So it clips elements. So on the display, the only elements which are inside will be displayed, and moreover, the elements will be squeezed in z-axis. So they will be projected, and there are no perspective. So we can use GL ortho to define this camera. So to make it possible, okay, I have a piece of code which does it. So I simply copy it. So look, I take a function init, which switch the matrix mode into projection mode, load identity. So I hope it's clear for you, and inserts a camera GL ortho, which clips the x min x max. So clips the area from x minus 10 to 10, from y minus 10 to 10, and from z minus 1 to 1. Because all objects are printed on the plane z equal to 0, okay, that's okay. So all objects which are inside this rectangle will be visible on display. I'd like to only mention that in OpenGL there are other kinds of cameras. So the camera which consider perspective. So for this camera, we have to specify the focal point and the view angle and the, let's say, direction. And in this case, the effect is, different because it's not orthographic projection. Yeah? Because so the objects which are near the camera are bigger. So I hope it's clear. Yeah. Okay, in this example, we use a GLUT. During your laboratory classes, you will get the instruction how we can use this library, how we can insert it in your in Windows OS. But I show you only how it is done in Qt on Linux. So it's enough to use GLUT and OpenGL library. It's enough to set the OpenGL to Qt, to set two libraries, and to set include path. That's all. Yeah. So it's enough to copy and paste to file, copy and paste 3 lines to use GLUT and OpenGL. Okay. So to use OpenGL, we have to initialize the environment. So it's not, there are some initial steps required to perform to do it. So here you have the code which let us to do it. So we we have to initialize the GLUT library. Behind the scene, the OpenGL is initialized. To initialize the OpenGL without the GLUT, okay, it is possible, but it takes, let's say, 50 lines. So it's easier to use GLUT. Then we have to initialize display mode. So look, here we have something GLUT double. So it refers to double buffer. Do you remember what is a single or double buffer mode for graphic cards? Okay, you can check it in our previous lectures about graphic cards, but this led us to set a, yeah, so we set two frame buffers mode. So the object or the image is prepared in back buffer, and then when it's ready to use, we can switch it in a single, refresh cycle to front buffer. Yeah, so the quality of animation becomes better. Yeah. Okay, then we create a new window position. So the position of the left top corner of window. We set window size and window text. So in this case, the window is displayed. Of course, in OpenGL, we have to display an additional window. So we have console. In console, we can only print characters. But for OpenGL, we have to create a new window. And finally, we have to register some callbacks. I will tell you something about callbacks later. And after that, we run something which is called a main loop. So let's try to do it. So I take a piece of code and then I will comment it. So I have function init. Then I take the main. So here you have the function which was on the slide. Okay. Okay, so I will comment this. First, I run it to show you how it works, what will be the effect, and then I will comment it briefly. So look, running this code, I have C rectangle true, okay. Okay, so running this code, you can see that a new window is displayed. The object or red rectangle is printed. But now I'd like to print my scene. Yeah. So let's try to. I'd like to tell you what is going on here. Okay. So we created window. The name of the window you can see on the top bar of the window. The window size is like this. Then init function is called. So init function sets camera. And here we have several things. So here we have GLUT display function. So display function is the function which is called whenever our scene needs to be displayed. And second function is key function, and this function is called whenever user press a key. So this is a little bit different than the way how we use keyboard so far, but it is an effect of the window application. In console, we expect, for example, when we need information from user, we run cin, but in this case our program waits until the user press enter. In window application, it is impossible because user can interact with application not only by keyboard but by mouse, by some shortcuts, and the applications may interact between. So it is not possible to freeze our program until the user press a key, because it may happen or not. So how it is processed? There is something like main loop, which process messages which are sent from OS. And messages contains information about the mouse action, the keyboard actions, other actions which are performed. And when particular message arrives, a program may react on it. So it reacts calling a function. For example, when a key will be pressed, it calls a function key. When redraw request is sent, it calls a function display. Okay, so therefore in OpenGL we have the callbacks. So to make our program work, I have to make a very bad thing. So I have to create a global variable feature, because display has no arguments. So it requires to use features, as global. So look, here is, the only way how we can do it. So now I can take my code and I can call for display, I can call for out of features draw. So I can draw all features, and then I can call swap buffers. So swap buffers switches the front buffer with back buffer. So it is, connected with this label GL double. Okay, so let's try to run it. So look, Mr. Korzeniowski, in back and front buffer, nothing is copied when you swap them. You only change the address of the memory from which your display takes data. Yeah? So there are no copying operation. So look, the effect is that, the circle and rectangle were displayed. So now I can try to, move them. So let's try to use the key callback. So W. Okay, so first I'd like to declare another global variable int active ID. So active ID contains the ID of active figure. So let's say that W means that I'd like to take figure index active ID. Let's say that it is 0, and I'd like to move it by 0.5, sorry, 0.5. Then I will use a key A to move my object left, so minus 0.5, 0. And the same for S. No, for D. For D, I move it by 0.5 right. And for S, I move it down. No? What else? I can rotate it. So let's say plus, maybe plus. It will rotate by angle, let's say 5 degrees. So this is my interface, but I can add, I can have additional command. Let's say the character, the brace, which increase active ID by 1. So if figure's size is smaller than active ID, then active ID plus plus. And opposite, the character, if figure size, no, if active ID is greater than 0, then active ID minus minus. And here break. Okay. So let's try to run it now. So look, my active ID is 0, so it corresponds to index of rectangle. So I can simply move it, and I can rotate it. Okay, it doesn't work. But when I switch active ID, so I change it to, oops, something is wrong. Let's try to Sorry, the command is if size is greater than active ID -1 is greater than active ID, if active ID is greater than 0, active ID. Why rotate doesn't work? Angle, load. Okay, it should work. So now I move it. I try to switch to rectangle. Okay, something is wrong with it. Okay, I'd like to show you another thing which can be quite interesting. So when I press, let's say, new, I'd like to create a new rectangle. So features out from active ID, not active ID, features, push back a new C rectangle 2 by 2 elements. And finally, I'd like to modify the active ID to be equal to feature size -1. So in this case, I add a new feature to my scene. So, or a new rectangle or new circle. Okay, so let's try to test it. So still, I can move it. When I press a new rectangle is printed. So now I can move this rectangle. When I press new, oh, sorry. Again, new rectangle is printed. When I press C, a new circle is printed. I can move it. So when I change the active ID, so I use brackets, I can modify or select different objects to move. Yeah. So look, the code is, so if you add a new feature, this code will be still valid. So look, from perspective of the feature vector, because we have here C feature pointer, it doesn't matter whether the object is triangle, rectangle, circle, so on, because it calls methods rotate, draw, which using polymorphism are fitted to the or matched to the proper object type. So hope it shows you how we can, so what are the benefits from polymorphism and from inheritance? If the rectangle, triangle would be, a separate class without base class, and there were no polymorphism applied, for every object I should have, a different container. So different container for rectangles, circles, triangles, and so on. So handling these objects would be also more difficult. Now it's enough that I select the previous or the next object in the container, and I can move them the same. Yeah? But in case I would have different containers, I should have another, combinations or shortcuts to select proper container and to select active elements and so on. So it makes this program easier. Yeah. Okay, so I think that's all for this lecture. So hope it gives you some impression about how object-oriented works. Of course, you will be practicing it during laboratory classes. Yeah. Okay, so thank you for your attention during this lecture. Hope it will be fruitful for you for your future, programming skills. And now I'd like to tell several things about the exam. Of course, I can post this code for you. Yeah, so maybe we do it like this. I put it in on GitHub, and there will be a folder with codes from lectures. Okay. Okay, so let's try to talk about the yeah, of course. I will apply upload lectures. Sorry for delay, but it's a little bit crazy time for me. Okay, but I'd like to tell you what are the elements you have to or you should know. Here you have an example of final exam from 2017, but it's similar to the so this year the exam will be a little bit different, but some assignments will be quite similar. So every year there are two similar assignments. So converting values between numeral systems. So we have value in hexadecimal, and you have to convert it to binary to hexadecimal. So you have to calculate it from different systems. I would prefer, so usually in stationary form, students cannot use calculators. Of course, in your when you have exam, remotely, okay, I can't verify it, but I suggest you to practice converting between different systems. It's enough to know what is the 2 to power 10. So you should know the powers from 0 to 10 for 2, and maybe powers from 1 to 3 for 16. So it will be enough to recalculate all these elements. Calculate results. So this assignment is about binary logic and arithmetic operations, but it refers also to operator precedence. So you should know what is the order of operations to calculate the right result. Okay. Then there are questions about all topics which were mentioned during our lecture. Of course, in stationary form, the answers are, given with several sentences, but during your exam, you will have the questions in a form which was used for quizzes. So there will be a multi-choice test, or there will be a place for entering value. Okay, so most questions will be like that. But I haven't decided yet, but I think that the exam will consist of two parts. So the first part will be like this. So converting values and multi-choice questions. And then there will be a second part, let's say half an hour after. So you finish the first part. And for the first part, the time will be a little bit restricted. So you will have 2-3 minutes per question, and there will be about, let's say, 10 questions. Yeah? And the second part will consist of up to 3 questions similar to this which are listed here. So you will have to answer with, so you will to write several sentences, yeah, to on specified subjects. Yeah, so it will be similar to the questions like this. Of course, you may expect some programming assignments. Usually the programming assignments will be like this. So there will be a code, and you will have to answer what is the result. Yeah, there may be some questions to transform code from one form to another form. But in this case, I have to correct or check these questions manually, yeah, because there's so many ways how you can write code that it is impossible to implement it in Moodle. Okay, so okay, so this is the first element, and now I'd like to, but I have to find it. Mm. Okay, I don't have an actual list of topics, but probably you have some, eh, maybe not handouts, but some. Okay, here is outline. Yeah. Okay, so it's here. So introduction to computer science outline. So here are topics which were which I mentioned during the lecture, but in this year they were no Windows, and they were no information about processors. So I have to delete it. So I update this list by deleting the elements which were not mentioned during the lecture. So remember, when something was not, some topic was not mentioned. So I haven't told you, for example, about FAT, NTFS extension file systems. So there will no be questions about it. Yeah. But most of these elements were mentioned. So I suggest you to know something about it. So what does it mean, something? Usually there are no questions about definitions. So I don't ask you, okay, what is the PCI? huh? Or what is the definition of double buffering? Yeah? But usually questions are more problematic. So what happened if we use double buff, or why in double buffered mode something may happen, or yeah, or what are factors which influence the hard drive or solid state drive durability and so on. Yeah, so you should, you know, process your knowledge and extract some elements which are important for this issue. Yeah, so I think it's a little bit harder than, you know, learning definitions by heart, but for me much more important is to verify whether you understand or not. You can answer in the blog where you will answer by a short text. You can answer by your words. So I don't expect that you know, cite me, or you take a Wikipedia and you copy paste, you know, some information. Uh, so frankly, the questions are defined like this, so it's not so easy to find the right, not maybe right, strict answer in Wikipedia, because you have to understand the text and then you can answer it easily. Yeah, so for those who understand some processes, it's quite easy to answer. For those who not, okay, it's more hard. Yeah, so I suggest you to try to understand what is behind. So what is the, let's say, the source of particular problem, or okay, topic is, so we had 60 hours of our lecture, so there's a lot of topics, so it's a huge amount of information you have to have. Probably it may be a little bit easier to answer the question when you are remotely, because I don't like it, yeah, because during the exams usually students are not allowed to use any, you know, additional sources. But okay, in this case I have no influence on it, so hope it will be easier. No, you don't need cameras. Yeah, there will be a Moodle. No, it doesn't influence the difficulty of the exam, but because I'd like to, you know, decrease the risk that you will communicate with others. The time will be restricted. Yeah, so there will be up to 3 minutes per question to answer. I mean the questions of multiple choice test, and there will be maybe 5 minutes to answer the questions, the more problematic questions when you have to write, you know, several words. Yeah, so yeah, so no, there are no camera, no other you know, restrictions, so I don't expect that you I hope that most of you will do it, you know, by your own. Even yeah, assuming that you even can have some additional, informations like lecture slides. Yeah, if you are able to extract the knowledge from the slides, that's okay for me. Yeah, but I suggest you don't to communicate with others. Yeah, because it's, yeah, for me it's unfair. Yeah. Okay. Do you have any other questions about the exam?
Yes. Um, During exam, if I understand you right, for example, we
So
have.
I'd like to mention that students who get 4.5 or 5 from laboratory classes will give credit for lecture automatically. So when I have access to your grades in laboratory classes, so I can easily, cope with this grades. But it I do it, in proper time. So don't worry, you don't need to, email me whether your grade is okay. The condition is that the grade should be issued for the first try, not for the second take of your laboratory classes. And the grade, and for students who repeat the semester, so for whom is the second attempt, even they have 4.5 or 5, they have to pass exam. Yeah. At what time? No, you don't. You shouldn't be, because if you try to solve your exam, so if I get your answers, I will give you a grade which was taken from exam, not from laboratory classes. So remember that you can't attempt to the exam if you want to get a credit for it. Yeah? At what time? Uh, let's try to set it or schedule. So as far as I remember, we set the first take on 10 February. Do we? Okay, so maybe is 10 o'clock okay for you? Okay, so I set it for 10 o'clock. And the second take was 26th February, so we can set it for 10 o'clock too. Yeah? Yeah. So I think that's okay for me, and uh, yeah, the exam will be on e-course. I will send you an email with information, but there will be a next category like quizzes. There will be exam first take, and there will be 2 quizzes. The first quiz, which will be opened on 10 o'clock, and there will be, let's say, number of questions. So let's say 10 questions, 2 to 3 minutes per question, so about half an hour to solve this quiz. And then will be the next quiz, which starts, 5 minutes after the previous will be finished, and there will be, let's say, 5 minutes per question, so about 15 minutes to solve it. No, there will be, yeah, due to, problems with, so yeah, the time will be restricted, and also there will be a one-way, flow in this test, because, okay, personally, if I had the, I'm not sure whether you work, alone. If I would sure that you work alone, everything would be, okay for me. So I would give you a possibility to move back, or give you a more time for it. Yeah, but I think that if sometimes you move because you just uh, understood something, but sometimes you get the right answer and you want to modify it. So sorry. So sorry, it is not possible here. Okay. So you can
Professor?
have some more additional, help for this quiz, which is not available in stationary form, but you have more restrictions, yeah, too. So
Professor, can you hear me?
okay.
Hello?
Yeah, about bad experience with quizzes. The quizzes verify your understanding of the knowledge. If you have more time to prepare, I suggest you to use some, questions from quizzes to prepare too. On exam, the questions, some questions may be very similar, but some questions will be, more detailed, because the questions on quizzes were, in my opinion, yeah, it's my perspective, were very general. But I suggest you to verify your knowledge based previous quizzes, especially you have some for those who had some problems with these quizzes. No, there is a general restriction for time, so you can spend 5 minutes on a single assignment and 1 minute on another assignment. So the first part, which consists of 10 questions, will take 20 up to 30 minutes. So there will be no restrictions in time you have to you spend to solve a single question. No? The same for other parts. So if you have 3 questions and you have 5 minutes, you can spend 10 minutes on a single questions and 2.5 minutes for other questions. Yeah, but remember that when the time is off, only the questions you answered in this time are considered. Yeah, so yeah, you have to have a strategy. Yeah, so it is dangerous, but it's up to you. So what time do you start it. So I think there is a clock which shows you the time remaining to finish. So you have to make the strategy by your own. Okay, so Do you have any other questions?
Professor, can I ask you something? Hello?
On a voice chat, okay, I can't hear it, hear you, but wait a moment, maybe I have something. Okay, yeah, now I can hear. So
Okay, can you hear me now?
yeah, of course.
Yes, I was repeating this subject and I wanted to ask you if the criteria for passing the exam has changed or, something new.
In general, there are yeah, most topics are the same. The difference is in STL, so I changed several things in STL, but it's in most the most elements about STL are the same. So
Okay.
the elements which I changed are, very specific. So I think they are very useful for programming laboratory classes, but they are not so important for from the exam perspective. There were no topics about processors we had last year. So you don't need to do it. And I skipped topics about file systems this year.
Okay.
So I think that
Okay,
there
Professor.
were
And
less they were less less topics than last year.
okay. And is it the same that like last time, if you get 4.5 or 5 grade in lab, you don't have to write the exam?
No,
Or it has changed
you
also?
have to, because look, it would be unfair to those who passed laboratory classes last year and they haven't passed exam, because they haven't chance
Okay.
to make to get higher grade from exam because their grade was positive. In your case, if you failed laboratory classes last year,
Yes.
so you had chance to improve your grade from laboratory classes. So I think it would be unfair for those who couldn't improve their grade because it was positive. Yeah, so
Okay. So I have to attend the exam.
yeah, you have to.
Okay. Thanks. That's all. That's all I want to know.
Mhm. Okay, so I hope that's all. So thank you for your attention. And if there would be any, questions about exam, you can write me. After first take, I plan to meet with you, of course, remotely, to answer your question or to tell you something about my impressions or explain some problems which were common for most of you. So, but I hope that we arrange this the date, after the first take. Okay. Okay, so that's all. So goodbye, and good luck for exam. Yeah?
Thank you.